Good afternoon. I apologize not for speaking French, but unfortunately I didn't have the chance to learn this beautiful language of many excellent mathematicians. I hope my presentation will show up. Okay, it is. Now here you see the map of Europe. Poland is up there in the middle. There are three basic informations on top. The population, much smaller than France, still not the least country in Europe. We have about 30,000 teachers of mathematics in Poland. What's important, 95% of those are masters of mathematics. Of course, trained later to become teachers. I agree with all the 7 principles that we heard in the last talk. I don't think there's any mathematician in the world that would not agree with those. But there comes a question how to implement that, how to convince people that this is the way. In principle, it's beautiful, but now you have these 30,000 teachers who have to change their way. You have parents who laugh when the kids are taught as they were taught, and you have children who have to somehow adopt to this stuff. And I was in charge of implementing this kind of change in Poland some years ago, and I want to share you the experience, how you can do it. Of course, not pretending that it's applicable everywhere. Okay, so it's just an example, and you will see what happens. So first of all, let's realize what are the conditions that we are living in. This symbolic picture shows that it really did change. The whole library fits into one pen drive. A phone cell, with the help of the cloud, brings you more information. That's a completely different world than the world that I lived when I was a student at elementary school and later at high school. And there comes a paradox. Yes, we are surrounded by information, but does it really help? I mean, this poor rat sitting in the library is not any smarter than the other one, even though the sources of information are there. There are other features of the temporary world. In my young days, the tasks that you encountered in life, divided into the standard things and the non-standard things, more or less half and half. Routines could help in many, many situations. Now it is changing, rapidly changing. The number of routine tasks is reduced also because machines are taking over these tasks. For example, simple addition and subtraction is really done by our students on a calculator. Even though I appreciate the value of understanding what it means, but still it's done there. But the number of tasks which are not so routine is increasing, and it's creating sort of mental danger to people because they are confronted with situations never met before. This is a reality. There's another feature. We are surrounded by things that would be hard to imagine some years ago. Lie becoming an official tool of politics. Fake news as reality. And how to deal with that within the education system. We have to react. There are 2 conclusions that I think, and we found in Poland, most important for the whole education, not only mathematics. One is to prepare students to be ready to deal also with non-routine tasks. So routines are not that important anymore. Non-routine situations are more important. And the second, very set circumstance, prepare students to recognize and deal with lies. These are the 2 things that are very, very important. And I will claim in a minute that mathematics is a perfect subject to deal with those 2 objectives. How to achieve that? Now we have the realities. The realities are that kids are attached to smartphones. Yes, they are not looking for books. They are sitting and not talking to each other even. I mean, this is the regular situation. I have seen such a situation in front of your friends' schools yesterday. It's global. Teachers don't have good answers what to do. I mean, students are challenging them because using smartphone is easy. Doing math problems seems to be hard. So they somehow are desperate, and teachers really don't have good answer. At least our teachers were really in a very poor situation. A standard answer is that you should practice and you will later see that it was profitable. And this is the outcome of this. Even though we had yesterday that a little nap is helpful, but that's the reaction of the organism. What was the standard way of teaching mathematics in Poland before we undertook this attempt to make a change? I believe it's so in many countries. You just have a list of concepts, some of them addition, subtraction, but also more complicated operations. I'm talking about the whole school, not just the elementary school when you deal with arithmetics. And you go concept after concept. Yes, you take a concept, practice it, then make an exam or test, and move to another concept. That's a very common way of teaching mathematics. It was common in Poland as well. It's very practical, and I think many people find it effective. My grandson, who is living in Arizona, practices this in a week cycle. Monday, new concept, Friday, test. I mean, it goes forever. So, and then come the questions quite often asked today. What mathematics do people really need? And what do we de-emphasize or remove? If you are not worried by these questions, then try those questions. What literature do people really need? And what do we de-emphasize and remove? Where's the contradiction? We forget something. Mathematics is like literature and art, part of our cultural heritage as well. We should not forget that. It's not only that you learn mathematics to be able to add numbers on your checkbook or wherever. It's also part of culture, very important part of culture because it has no national biases. It's really a common core of the culture which came from the Greeks long ago and should unite Europe in a sense. This is a very important aspect. So we decided to change the scheme just by setting 3 basic goals for our math education. That was the year 2008. We said, whatever we teach, it should serve one of those 3 purposes, some of those to all of them. The first one is mathematical reasoning and argumentation. That was one of the first points out of those 7 that we had just a few minutes ago. So that you learn what is the way you get something from something in a sure and secure way. Mathematics is the only subject that these kind of reasonings are not based on someone else's authority. That is very important that you learn to argue on your own. You make arguments and you are sure they are true and they will be true forever if your proof is correct. It's not so that the teacher said it is correct or that someone else discovered it's correct. That's your full responsibility. Mathematics is the only subject that has this feature and also the best school to learn reasoning, because when you reason, even if you make a mistake, you don't challenge someone else's authority, so it's safe. The second is strategic thinking. That's a shortcut for saying you'll be more and more often in situations when you have to choose one of 2 or more ways, go left or right with your solution. You have to be prepared to make the decision. It's not that you stop and you think, how were we doing that in class? It's a new situation and you make the decision and you are ready to go back and go the other way if it doesn't work. That's a very important task in today's world. and we do this. And the third one is very known and common. This is the modeling, I mean applying mathematics to solve real problems. Mathematics, I have my private definition of mathematics. Mathematics is a science about completely defined objects. When you build a model, you just put the conditions that you assume about the object, which approximate the reality. Most of them you skip. Then you solve the solution, and then you see what came out, analyze the outcomes. So this is well known. This well-known third topic. But the first two are important because they are sort of responses to these two challenges. Strategic thinking is a way of dealing with non-routine tasks. When you don't know by heart how to move to solve the situation, you have to take a risk to go one way or the other way, and you have to be prepared for that. In real life, it can be really tough. But when you have this special mathematical situation that you know very well about what you are talking, it's much easier to practice. And the second, reasoning and argumentation, is a tool against lies, because a lie usually contains some contradiction inside. And if you are fluent enough with reasoning, you can discover those contradictions and then show that's a lie. That cannot be true because it contradicts something else that is also said. So we decided to form our national curriculum on two layers. Layer one are these general requirements, which are just the three pillars that I mentioned before, and the specific requirements that list the topics that you cover at school. And there's no big revolution here, but the objective is different. For example, of course, we teach kids in high school how to solve a quadratic equation. I believe most of you have learned that, and most of you have forgotten how to do it. And no harm done, in fact, because if you don't use it, it's not. But you can use these lessons about quadratic equations to teach the reasoning when you have to prove something about the roots of the quadratic equation, or you can teach how to think strategically when you have to fix some parameter that will decide that this equation will have this or that form, or you can solve a word problem by using a quadratic equation. Then you do the modeling. So these are the objectives. Now, how do you implement this? It's in Polish, don't worry, I am not going to translate this. You see, it looks nice on the surface, of course. So you have these three main objectives. How do you make the implementation of that? Of course, there's always a danger that teacher takes this curriculum, sees the first page, the basic objectives, turns the page around and sees the quadratic equation. It goes like before. But for this purpose, we have national exams. On the national exams, starting from 2009, we started to give problems which check the abilities of kids with respect to these three areas. And the only thing I wanted to show you here is that this last sentence starts with the Polish word for proof. Proof that something is true. Very simple something, really, not very demanding, but this word was not present on any of the Polish national exams ever before. They just have it. And so, this is a high-stakes exam. It appeared in textbooks. It came to the classrooms. And there came a surprise. Because before, of course, teachers of mathematics knew that proving is important in mathematics, but they somehow presumed that this is only for the more talented kids, that we can have a special class and there we teach how to do this, and the rest must have just to learn routines because then they will pass the exam. Now, there came a surprise that the kids don't oppose this kind of questions. They, in fact, find it interesting. Another example, and another example. That's an example for an exam for the lower secondary school. This is a body that there exists in no textbook for Polish high schools. That was just a surprise for the kids. And the question is, find the surface area of this body. And they did it. And then there were comments on the website of the examination commission. One of those was like this. I calculated like crazy, while it was just enough to think. The surface did not change. What is inside was outside. And if you wrote just this sentence, that was the full score. This kind of questions appear every year on those exams. They have this feature that it's always something completely new for the students. They don't oppose, and the teacher don't oppose either, because they see that it brings questions to the classroom next week. Okay, can you show us similar problems? Because it looked interesting. I didn't have to work hard to solve it. And there comes a surprise at some point that it's so easy once you understand it. And then in 2008, we got the PISA results. And I must say, I'm not interested at all in the lead tables. I mean, I will not make a point of the fact that Poland is at some position. This research had a completely different meaning for us. You see, when you discuss with teachers the question, why don't you give more problems which have reasoning? The answer is always the same. It's difficult. It's difficult, it's hard for the students, and it's very true. It's not as trivial as following some known procedure. But when you have this, the results of PISA, you forget about the lead table. You just look at the table and says, but look, this is a reasoning problem, and in Poland, only say 4% of students could do this, whereas in Germany, it was 10%. How come? Are they more talented than our students? And then we show other countries. And thus, teachers started to think, okay, maybe we can do something about it because we are as smart as the German teachers. Our kids are not less smart than the German students. So why don't we have this? This is the basic value of this research, that you can look at the results item by item, in fact, and see what are the problems which your kids have in comparison to other countries. That's a very objective comparison which really helps to convince and to move in some direction. So these are the outcomes. You might be familiar that these results are divided, scores are divided into levels of competencies. And the top level is at the right end, the least gift talented, or the students who got the worst result are at the left end. So after this change, we have reduced by half the number of the weakest students and increased twice the number of the best students. You could say it's wonderful. It's not wonderful. It was easy because the world is so bad in teaching mathematics. That's the real truth. I mean, it was so easy to improve. What does it mean, this 5%? It's about one student per class, statistically, yes? So only one student per class can deal with the most complex problems, which are not very, very complicated, in fact. But before, we didn't have this one, and now we have it. This is accumulated. I move on. I will skip these tables, which show this progress. This is interesting. The top graph, what does it show? On the top graph, you have the top graph presents all the reasoning problems in the PISA test. Some of them really tested the mathematical reasoning. Part of them, there were 11, I believe. And these boxes, gray boxes, show what fraction of the students in the all OECD countries could solve this problem. So the first one was very, very hard, then they get slightly easier. Now this orange rectangles are the results of Polish students in the year 2012 on these problems. Whereas in the previous cycle, we were somewhere in the middle of these boxes. And the last picture, it's also very interesting because it somehow destroys a myth. The myth that these kind of problems are only for the most talented students. Only those can make progress. Here the graph is built as follows. I take one of those problems and take the population of students who did this problem and divide them into centiles. In 10 groups, the weakest students are at the left, the best on the right, and I catch what fraction of those students could solve this particular problem in the year 2003 and in the year 2012. That's exactly the same problem, the same wording. And you see there's a shift up across the scale. It's possible to improve all students on this kind of problems. You have only noticed that they exist and get the students interested. So we come again and again against the problem of motivation. Yes? In order to get this result, you have to motivate the students. That's motivation. The lack of motivation explains many things. For example, this puzzle about this Indian market, kids who can deal very well with rupiah. This problem was observed long ago, and the first research about this was in the 60s about the Brazilian kids. And the answer is surprisingly easy. I mean, they don't care if they make subtraction and some digits are messed up, but they care if they lose 100 rupiah. Yes, it's just a matter of motivation. Money is a serious matter. Problem in classroom is something which is a play, a game with the teacher. Many students say, I don't care what the result is. It's too abstract, I don't need that. They don't realize they need. That's the reaction. There was a very, very good experiment made in the 60s. There was a very famous problem in the didactics of mathematics. You give the following problem to the 13-year-olds. You have 1,500 people and you have to transport them by buses. Each bus takes 51 people. How many buses you need? It was tested in many countries. On average, 40% of kids can give the right answer. But in the 80s, someone came by accident with the following new idea. Why don't we give this problem to students and they should give the response on the order card when you order the buses? Not just as a math problem, but you have to fill this order. Okay? The correct response rate jumped up to 60. Kids knew it's a serious matter. It's not just a game with the teacher. Of course, when you give as a math problem, they say, well, I know there will be no buses, there will be no crowd. They just give us a problem. When you deal with something which looks probable, they treat it more seriously. So, question of motivation is the hardest one. This is the toughest job of a teacher, to motivate the students. I know many wonderful teachers who can do this. Very sometimes easy question, which catches the attention of the students and they start thinking. And sometimes they cannot stop thinking. I mean, they get so engaged, they quarrel and fight. It's the art of finding such questions which drive them in the correct direction. That's really the basic task of a teacher today in any subject, in fact. How do you teach reasoning? There are many ways. I give you two examples. One is from a Polish textbook. Teacher came across the idea that he will give just a simple Sudoku table. I'm sure you all know what it means. And he asks the question, why can't you put in the star place digit 1? But you have to write the answer. What happens when students start writing? They write mathematical reasoning without knowing that. They say, if one was in this position, then in the other position there couldn't be something else. And then he complicates it, and it becomes proofs by contradiction, and very long reasonings. And then after this practice, he says, now we switch to geometry about triangles, but you will do exactly the same. Yes. And in fact, they already learned what an implication means, what a contradiction means, and so on, because this game is just a very simple axiomatic system, nothing else. It's pure mathematics. Mathematics does not have to deal with logarithms and trigonometric function and so on. It has to deal with it if you want to have an engineer in the future, but a well-defined situation is a good stuff to train the brain to think. And if you motivate kids like that, they do it without any hesitation. And they apply without knowing this, but this sits in the brain somewhere. They know the De Morgan laws and so on, how you make a negation of a of two sentences put together. No problem. Another problem that comes from a book which is used at MIT, the course, The Art of Insight. The question is what's the volume of the $1 bill? And I know the teacher who teaches that, that's Sanjoy Mahajan, who says, well, that's the very first problem he asks the students. Of course, they have no problem with estimating the width and the length of the bill, but how to estimate the thickness. And then he says, go to the printer and look at the pile of papers, how thick it is and how many pages are in there. And then they catch it and they can do it. The small discovery. And then they make a very good estimate. Then he says, at the end, I take this bill, fold it so that it looks exactly like half a cube centimeter because the answer is about this size. So it is possible to teach those things. And it's so important that it's also becoming part of the PISA next cycle, 2021. I'm almost finished. That's the last but one slide. So there will be a quarter of the items will be very simple reasoning items. And I must say that even the weakest countries insist that their kids should be measured this way because they know this is the future. This is the basic knowledge. And there will be a special additional measure that will try to catch how well the kids can do that. This will be published very soon, just after announcing of the outcomes. And this is the summary. So just a few sentences. Mathematics is today much more than a toolbox. Forget that you teach them concepts one after another. It doesn't help. Another concept-oriented teaching does not fit the present challenges. Teach the method of mathematics. And I try to explain how you can do this. As it has always been, mathematics will then be the best answer to problems we face today. And why? It is so because mathematics is one of the best parts of the cultural heritage of humanity. Thank you.